Hey there. So I've got one more sort of lingering question in my mind. I know we're using all these Firebase UI classes for basically everything in the app to do with lists, but I'm confused why Firebase Array doesn't just grab an array list. Any Oh, hey. Looks like JP's texting me and he wants me to go to Google and talk to a Firebase expert. Well, that's pretty cool, but I'm not free. I told Kagure I'd cheer her on in the finals of the Cheesy Flakes Cheddar Cheese Cook-Off Championships. But you're available, right? Why don't you head over there right now and report back what you learned? Want to borrow the company bike?
So how does Firebase treat lists and arrays?
So lists in Firebase deviate a little from the traditional array concept you're used to. The big difference is in Firebase, we always have these key value pairs. That value might be an object with more keys, so you can have this hierarchical structure, but it's always a key and a value. An array in a traditional situation is a key value pair where the key is an integer and the pair is whatever data is stored in that array. Firebase doesn't quite like that. You can put in integer keys. You could make an exact normal array structure in your Firebase, but when you're building real-time applications that deal with information that's changing quickly or a lot of new information is being added, there's a really good chance that two people are going to try to add the same new integer key at the same time. So if we have 4 items and somebody adds a fifth and another person across the planet adds a fifth, one of those people are going to win and the other one's going to lose their data. That's why in Firebase, we use this concept of pushing in with these unique push IDs. These are pretty much globally unique identifiers that will be sorted in the same way as integer keys, where if I push in later, it will appear later, and they essentially function like an array. The only difference is instead of having 1, 2, 3, 4 as our keys, we have these long, complicated strings. But once it's in there, you can pull the data out, you can loop through it, you can do everything you would on a normal array, especially if you're using one of our helper libraries. It's just the structure looks a little bit different in your Firebase.
So why did Firebase take this approach?
It was mostly our concern for the real-time aspect. We wanted to make it really easy to build data that multiple people were editing and collaborating on at the same time. And like I said, you can run into these race conditions where you have multiple people trying to add on to the same list. And integers, it's just too likely that 2 people will write to it at the same time. Using these unique keys, we can guarantee that if 2 people or 100 people in the world write to this location at the same time, no one's going to lose their data. No one's going to get overwritten by somebody else. They'll all be unique, all the data will be there, and you can ensure that all your users' interactions will be safely stored in Firebase.
So what are some of the pros and cons of this approach?
Well, the con is that it's a little unusual. People are used to dealing with lists as arrays. They're used to those integer keys. And when people look at their data in Firebase, they see this familiar push method that comes in any of our SDKs, and they assume it's going to act like a normal array, which for many reasons it does, but the big change is that we use these unique IDs. So that's probably the real big difference that people see, is just that it's a little unnatural. But as soon as you realize why we make these decisions and why we're helping you to make sure that your application scales and runs efficiently at any size, then it makes a lot of sense.
Well, are there any times that you need to use an array, and how would you do it?
There are definitely times people want to use arrays, and it typically has to do when you're integrating with an older system or some existing application that is very committed to using these traditional arrays. And you can do that in Firebase. You can use integer keys in your Firebase. It's completely fine. The important part to remember is just that if you have a lot of people writing to this data at the same time, trying to change that array, trying to add in new things, you're going to run into issues. But if you have, for example, a .NET application that every 24 hours it's pushing in a list of your top 100 users into Firebase, you can use normal integer key store just like a normal array, and that's fine because you only have your one server ever writing into Firebase. There's not going to be any race conditions. There's not going to be anything like that. So it's completely okay. And Firebase does do some handling to help transition that into a normal looking array, especially if you're exporting JSON through our traditional REST API, which is what you would be doing if you're using .NET or any PHP, any of these more traditional stacks. So yeah, there are definitely situations where you can do it, and we support those. We just generally don't recommend it for any quickly changing, quickly moving data.
Now you mentioned push IDs. How are push IDs generated, and what makes them so great?
So push IDs can be thought of as a globally unique ID. They're not a traditional GUID that you've seen before, but for all intents and purposes, they are completely unique and they're a little magical in that they're lexigraphically sorted, which means that if I push in now and I call it pushing in later, it will sort as you'd expect. It will come later in the list. We do that by basing it off of the time of when you pushed in. We look at an epoch and we say, okay, what is a nice version of this that we know will sort properly? And then we also add in some extra logic on top of that to make sure there are no collisions. So if I have a server running that's pushing in 10,000 items, we make sure that even if you push those all in on the exact same millisecond from the same machine, there will be no collisions. So there's a lot of logic behind it, but the important part is they're just strings that will lexigraphically sort in the correct order, and they're so great just because they avoid all your race condition problems that you might have using traditional arrays.
Well, Abe, thanks a lot for your time. I think it's going to really help my friend out. I think she's going to be able to continue developing her Firebase app, and yeah, appreciate it.
Awesome. Thanks
All
so
right.
much.